Okay guys, today we're doing 3.7 derivatives of natural logs. Let's get started. Okay, first thing, just like when we were doing the derivatives of exponentials, let's just remind ourselves some properties of the natural logs. This is a graph of a natural log of x. Okay, remember this is the point you need to know. Natural log of 1 is 0. You need to know that anything between 0 and 1 is negative. Yeah, negative. It's an NEG, negative. Anything after 1, anything from 1 to infinity is always positive, yeah? That's something that's important to know. Okay, what is the inverse of natural log of x? Well, the inverse of natural log would be exponential, e to the x. It's what the base of the natural log was. Is natural log continuous? It is continuous for the graph that it has, but it is not continuous from negative infinity to infinity, because you can't have negative values inside of a natural log. So not continuous everywhere, just because you can't have negative natural logs, and you can't have a natural log of 0 either. Okay, the limit as x approaches negative infinity. Well, as you go way over there to the left, negative infinity, there isn't anything. So there does not exist a limit over there. As you do the limit as x approaches infinity, it kind of looks like it has a horizontal tangent line somewhere possibly, but it doesn't. So the limit as x approaches infinity of natural log is going to be infinity. It just slowly continues to climb forever. Okay, last thing, what is the value of natural log of x that you must know? We just spoke about it. Natural log of 1 is equal to 0. Remember, the other one you should know with e. It's the inverse of it, which means you can switch the x and the y's. E to the 0 equals 1. Yeah, that's not the e one that you should know. Okay, let's go forward. Okay, the derivative of natural log. The answer of derivative of natural log is 1 over x. Now, let's give you a shortcut here doing it. If it doesn't have just an x in there, if there's something other than an x, we're going to call whatever's in there u, just like we were doing with the exponentials. And it's going to be du over u. Derivative of the inside over the inside. Du over u, du over u, du over u. Now, let's remind ourselves of the other one. Okay, the other one is du e to the u. Remember, notice how the e stays in there. Notice here, natural log disappears from our derivative. You will not have a natural log anywhere in there. Okay, let's do a couple practice problems here. Okay, y prime. Okay, call the inside u. We're doing this the same way we did the e. 5x squared minus 4x. You write down the derivative. 10x minus 4. Okay, it's du over u. 10x minus 4 over 5x squared minus 4x. There you go. If there's anything that you could factor out and cancel, simplify this, you could. This one does not have anything where we can make it more simplified. So that's our answer. Notice the natural log disappeared. Now let's remind ourselves of how we were doing the e yesterday. Remember, we were doing that exact same thing, u du. Put this here for a reason, okay guys? U is 4x cubed, du is 12x squared. Okay? Now, so if you're doing the derivative, remember it's du e to the u. Du e to the u. Remember this one's just du over u. Okay, du e to the u. 12x squared e to the 4x cubed. Notice how the e came down with it, stayed with the derivative. Notice how it does not stay with the derivative with natural logs. Okay, let's try a more difficult one. Find the instantaneous rate of change below. Remember, instantaneous rate of change means derivative, right? That is another key word for derivative. Okay, so there's multiple ways to do this one. You can think of that divided by 4. What I usually think of it as is a 1/4 in the front. Then we're going to have du over u. Yeah? Okay, so let's do the du is going to be 3x. Du is going to be 3. Okay, it's du over u. So the derivative is going to be 1/4 du 3 over u, 3x. Okay, well, if you notice, you can simplify this. The 3's cancel, leaving us with just 1 over 4 times 1 over x, which is going to be 1 over 4x. There's another way to thinking about this one. If that one's good with you, stick with it. You can also think about this as if we're going to take the derivative, it's going to be du over u. You still have it all over 4. Okay? Du over u, so du is 3 over 3x over 4. And if you want to use sandwich method, you got to throw that 4 over 1, right? 3 times 1 is going to be our new numerator. 3 over 3x times 4x would be 12x, which can simplify to 1 over 4x. So whichever way you want to think about it, this being the first method, the way that I do it, this being the second method, the way that you could think about it, whichever way you want to do it is more than fine. Just make sure you get the same answer. Okay, that is everything I have for that. And good luck on the worksheet.